Do you guys have any questions, first of all, for yesterday's problems that you guys wanted to go over?
We could go over the last one.
Deeper copy?
Yeah.
Cool. Okay. Let's dive right into this guy. So, deeper copy, they'll want to deeply copy a two-dimensional array. Okay, so I think these kinds of problems are really good for that sort of strategy that I showed yesterday, where you just break a problem down into smaller problems. So they want you to do a two-dimensional array, but I would first solve the one-dimensional array first, and then are you allowed to use slice here? Does it say you can use slice? Let me see. That unlike slice will copy a two-dimensional. I guess they don't really tell you if you can or can't, but regardless, I would try and use the approach of solving just for one dimensional first. So, and this may seem like super trivial, but with this example, we'll be able to see with this kind of approach, you can actually solve two-dimensional arrays or three-dimensional arrays or four-dimensional or like as many dimensions as possible. This kind of strategy will allow you to solve that. So it won't be just necessarily like two-dimensional only, I mean, for now we'll focus on that, but then I can go into like how you can use this to solve for as many dimensions as there possibly is. So we just have an array like this, let's say, and then we have a function called copy 1D or something, and it just takes in a one-dimensional array. Does anybody want to volunteer like how we could approach this?
So to copy the whole thing, you would just do slice, right?
Yeah, you could do that. Perfectly fine. It doesn't say you can't, so I would just do 1D array dot slice, and that would give me the copy of that one-dimensional array. So now I need to do this for a two-dimensional array. So let's so basically we'll db copy a two-dimensional array. Okay, so let's say that, I mean, I guess in this case, because let me think here. I think it would be helpful to actually in this case just implement out basically what slice is doing, which is actually looping through and creating a new array and then adding those elements into the array. I mean, technically we don't have to, but first we'll just solve it the normal way, and then we'll see that basically breaking the slice down into what it's actually doing is going to be helpful in seeing that like it's really just sort of redundant. But we'll see. We'll try this out first. So with deeper copy and then 2D array, I guess the first thing we'll want to do is, the reason why I said slice is a little confusing here is because if we actually did the loop, then we would see that we also need a loop here. But basically what I'm envisioning is basically having a new array that is going to be our copy array, and then basically using the for loop is less than or equal to 2D array dot length, and then I plus plus, and then basically we need to either add the element itself if it's a primitive value, because we don't need to make a copy of those, because by default they're primitives, and yeah, we only need to make a copy of the complex values, the complex types. So we could just
So
do.
there, would you have to check if it's an array?
Yeah, exactly. So that's like kind of the point of this, I guess, is to check, are you an array? And if you're an array, just use this slice method, and then add it in. If not, then we can just add the element itself. So we'll just say let element equals 2D array at I, and then we just do. Does anyone want to volunteer if they have any ideas on how to check if an element is an array or not?
It's array dot is array.
Yeah, perfect. So array dot is array element. So what would we do if it is an array? Basically, if it is an array, then we know that it's an array, so we could just copy it using this function. I mean, we could have sliced it too, but I'll get to like, I'll try to tie this together, and this is kind of like a little bit of, it could be like a little bit of an introduction to recursion as well, but I guess I'm not gonna go too deep into it. But here we have array. If array dot is array, then we could just say new array dot push copy 1D element. And so now we're pushing into this copy array. We're gonna copy the element. Else, what should we do if it's not an array? Basically, we can just push that element directly. And then here, we'll just return new array. So I guess the reason why I wanted to not use slice here is just basically to show that like it's pretty similar what we do in terms of like what slice actually does under the hood. Is it does a very similar thing where, you know, you have your new array and then you just loop through it's very similar where you just do this thing. But I mean we essentially, we can keep this. It won't break if you don't, because technically, you know, we could still do a check if that element is an array, even though we know that it won't be an array in this case because it's a 1D array. We could still keep the same logic, and now basically that kind of is recursion in a way, is like you're using the same function to solve the problem. You're using like the function itself. So I mean, but not to get into that too deeply right now, but we could just remove that, and then here we have this. So and then here we just return new array. Yeah. So if we break down the slice, and actually what it's doing is it's doing something similar to this under the hood, although this is just, slice will just, you know, enable you to do it a lot faster without having to type out all this code. But just 1 second. But yeah, this kind of shows that you can, by using a very similar logic, you can break a problem down into like the simplest unit, which is just if it's one dimensional, like just solve for that case, and then essentially you can use that to solve for a more complex case. And yeah, often you'll find that sometimes it looks somewhat similar, like the logic. And in those cases, that's when you realize like, oh yeah, like if something is very similar, then you can just kind of combine them together. And that's where recursion comes in, where the functions that you're using to solve the problem are just both look very similar. So you can kind of like smash them into one function and then use that function within itself to solve problems like this, where it's like nested. And basically you can use the same, very similar logic to solve this subtype of the problem and this subtype of the problem. Like the logic is very similar, but there's also obviously minor differences. Like this one has like the if condition. But once you see those similarities, you can start thinking, oh yeah, I could probably use the same problem, the same function to solve something like this, where it could be nested however many layers, and it would still be able to solve it. But for now, I guess the important part of this is just this function is essentially saying like, oh, okay, so if you encounter an element that is not that is an array, then you want to copy that element and then put that copied element into the new array. And at that point, it'll be copied. It won't share the same reference to the existing array. And when we get to the recursion lecture, we can go through how to solve this recursively, but it's very similar. Like basically, with some slight modifications, you can make it so you can solve like not necessarily only a 2D array, but also a 3D array or a 4D array, or however many layers. Are there any other questions from the problems? If not, then we'll go on to the higher order functions lecture. Where is it? Okay, so higher order functions, basically they're really important, and I'll sort of give an example of like their use case in everyday websites. So I'll make a practical example. But basically they're when we pass functions into other functions. So we've been used to passing numbers into functions as parameters, or we've been used to passing strings into functions as parameters, or booleans, all those objects, arrays, but we haven't really encountered passing functions into other functions. So basically a function that takes in a function as a parameter, as opposed to like a string or something, is called a higher order function. So they're not very special, actually. We pass numbers, strings, objects, and arrays into functions all the time. So why can't we pass functions as well inside of other functions? And we can. So they're special because they're not very special. Like one would think that we would treat them differently because they look so different than other data types, but they really aren't different at all. And you can just pass them around as freely as your heart desires. So yeah, we're used to passing all these other data types, but we're not used to passing functions. But this is a key component of what allows websites to function in an event-based manner, is the ability to pass functions into other functions. They seem to be like a different category where, you know, we just imagine them to only belong in that place that we're creating them, but really we can just pass them around like any variable. So us calling functions first class objects, it's another way of saying treat them like any other value in the language. So we can pass strings into arrays, but we can also pass functions into arrays. And here's the difference: is we're not calling the function, we're passing the value of the function in. So we can call them at a later point, but we're not calling them. So let's do a quick example here. So can anyone tell me what this would log? And then we push this into this array. We do eating funcs dot push eat food, right? So how would we call eat food now if we wanted to call it? Anybody have any guesses? So eating funcs now has eat food, the function, as an element. So how do we call that function? What we could do is basically just do eating funcs 0. That gives us our function now. And so now we can just call it with wings. And it'll give you I am eating wings. So we're passing, and notice that we're not passing in calling the function, because at this point, does anybody know what the value of eating func 0 will be if we passed in invoking the function? It's definitely tricky, but it would just give you undefined, because it's not returning anything. Log this. It's giving you undefined. So the reason you're logging this is you're still calling it. So while you're pushing it, you're calling this function and it's logging this thing. It's going to run lines 2 and 3 while you're pushing it in. But when you're trying to access the value, it's undefined because you're not returning anything from this function. So basically if you don't explicitly return anything from a function, it will, if you're trying to get the value of the invocation of that function, it's going to be undefined. So, you know, let's just try to do a different example where you have something like add, and then it gives, you know, num1 and num2, and here you just return num1 plus num2. You're actually returning something. And here you're doing add 1, 2. Does anyone want to guess what this will log when you're pushing the invocation of a function that actually returns?
So it'd be 3?
Yeah, it'd be 3. So now you're actually getting a value because you're returning. So it is calling the function, but the concept of this first class functions being first class objects means like you can pass it in here And now you can just call it at a later time, whenever you like, from inside the array. So now you're passing not the function call, because we're really used to just invoking functions after creating them, but we're not used to passing them around as if they're variables, but they really are. And so you could just, this is the same thing for the most part. I mean, it's definitely a little different in terms of like what's going on under the hood, but you just think of this as doing like, const add equals function. And now add is just a variable. This is a variable with the name add, and it happens to be a function that you can invoke at a later point, but you treat it the same as if it was just a regular variable that wasn't a function. But the fact that it is by virtue of it being a function, you can do stuff like this where later on you could actually invoke it. Whereas like if you were to pass in a string, you can't do this obviously because you can't invoke strings. So that is the one difference, is later on you can invoke it, but before you invoke it, you can treat it exactly the same as anything else. And why is that important? Like, who cares, right? Like, why would we ever like pass functions into arrays? Like, that seems kind of contrived. It just seems like some theoretical thing. Like, yeah, it works, but why should we care? Oh, damn. Well, we should care because that is what drives the entirety of the web, is this event-based callback pattern, where essentially you're passing functions into other functions, and you're saying, whenever this happens, like, call this function, which is basically like the whole core of like everything. Like, when I click this happens. When I click this, a function runs, and this happens. When I click this, a function runs, and this happens. Right? It's all event-based. So it'd be something like, this would be something like settings, right? So it'd be something like settings dot on click, right? And then that's a function. Like, when you click that, something will happen, and what will happen? Well, basically you could say function show settings, right? And then this, I don't know what it exactly does, but let's say it, shows settings. Then you do settings on click, and then you pass in show settings. And basically you're not calling that function at that time, because you're saying, oh, like, later on, call this function when something is clicked. And so this is basically a big part of websites, is like this event-based, event-driven thing, because you're not the one that's controlling, invoking all the functions. Otherwise the user would have no control. Like, you would just go on a website, and if you just called all the functions, then it would just happen, and the user would be like, I can't do anything. Like, all the functions are just being called and things are happening. But if you want to give the user control, then you need to say, okay, so the settings is an element. Like, when this element is clicked, call this function, and you're never going to call it. That's implemented by somebody else, like somebody who worked on basically HTML and browser based technologies, like created this function that they'll basically detect when something is clicked, and they'll call your function, but you're giving them the function to call, but you're not implementing the code that actually calls the function. That's already, somebody else wrote that code, and it's like ingrained in the browser itself, or ingrained in whatever library you use, like, to help you develop web applications. But yeah, this is the exact idea of callbacks, or higher order functions, is somebody made this function which is on this object. So settings is an object. It contains a function called onClick that takes in a function as a parameter, and you're creating that function in your code, and then you're passing it into this method on this object, which will, in the, somebody, made this settings object, and it has an onClick method that itself takes, a handler function that you're passing in, and it's gonna like say like, okay, so like detect if something is clicked, and then if it is clicked, then it's going to call your handler function. And so you're not writing this code, like somebody wrote this code, but this is exactly the concept of higher order functions. This on click is a higher order function because it takes a function as a parameter later, and at a later point it'll call it, you know, when something is clicked. Like it'll something like, you know, listen for click or something, and then when it actually happens, when that click happens, then it'll call your function. But this is why it's important. You're usually not going to pass functions into arrays, and then like that's something that's a little bit contrived. But what's not contrived is passing functions as parameters into other functions. That's like done very frequently and has a lot of useful use cases. So yeah, when we log this array, it's just gonna have a bunch of functions in it, function, but they haven't been called yet, so it's not gonna be their values. But yeah. So how do we call all the functions in the array? Well, yeah, we can loop through and we can actually just call them. Each element is a function, so we can invoke the function. As we pull that element from that array, we can now invoke it because it's a function. Does anybody want to guess what this will output to the console when we run this loop? Basically,
I think it would be like, happy function all the way.
It would be I am happy, I am happy, I am happy.
Yeah. It would just be I am happy, because element is happy function. It just has a different name. It has a different variable name, but element is now synonymous with happy function because we've just given it a different name, but they both are the same function because we had been storing it in an array and now we're pulling it out of the array, and we happen to give it another name, another variable name, but its identity is the same as happy function. It's the same value.
David, unrelated, but
Yeah.
did you need to record this?
Yeah, I'm recording it.
Oh, okay. Sorry, I didn't see little record dots, so I wasn't sure.
Oh yeah, I'm just recording it. I just use QuickTime instead of the Zoom thing. I'm just used to it, so I just use QuickTime, and then yeah. But
Okay,
yeah,
cool.
It's being recorded. So yeah, we kind of went over this. We could pass values into functions like strings, objects, arrays, but we could also pass other functions. And the reason being that, sometimes you don't always want to call a function immediately. You want to create a function. Like let's say, you had a function called bake cookies, but you don't know when you want to bake the cookie. You know that eventually you're going to need to bake a cookie, so you're going to write that function, bake cookies. But, you can pass that to another function called like bake cookies when you have all the ingredients or something. And so that function checks, let's say it just constantly checks your fridge to see if you have all the ingredients that you need to bake cookies. And if it doesn't, then it won't do anything. It'll check. If it doesn't, if you don't have enough ingredients, then it won't do anything. But then all of a sudden, like you go to the grocery store, you buy butter, you buy eggs, you buy cookie dough and chocolate, and all of a sudden you have all the ingredients, so now it's going to call that function. But you're not always going to create a function and call it right away. So sometimes you need to create a function that will take a function as a parameter and then call it. Or sometimes you need to pass to another function, a function that you wrote, telling that, basically giving up control and saying, hey, look, whenever you see fit, like call this function. Not necessarily me calling it all the time, because a lot of the web is user interaction based. So it's saying, hey, look, when the user hovers over this thing, call this function. but I can't call it until the user hovers over it. So that's why I basically need to pass it as a parameter, but I'm not gonna call it, I'm not gonna invoke it. So here we're passing a function as a function, as a parameter. So does anyone want to guess what this would log? If we called logs a type and we pass it a function, what would the output be?
It'd be function.
Yeah, it'd be function, because it's just like strings or objects or booleans. It functions the same way. It's just we need to like get away from the idea that functions are different and they should be treated in a special manner. Like they're really the same as any other data type. The difference is you can call them, you can invoke them, but you don't have to invoke them right away. You can pass them to something else and say, look, you decide when to invoke it. I'm not going to decide. So yeah, this is exactly what calls a function does, is it calls that function that is getting passed in as a parameter. But let's say, you didn't write this calls a function, like somebody else wrote it, right? And they expose this function to you and they tell you, pass your function into this function and that code is going to handle calling it. And you necessarily don't even have to write that code. Like somebody else wrote that code and they're allowing you to use that function and saying, look, give me a function to run when I see fit. And that function will be the one that's invoking it. Any guesses what this will log?
I am happy.
Mm-hmm.
I am happy.
Yep. Great. Yeah, it's just another functions are just, when you don't invoke them, they're just merely values that you can pass around. And the difference is, like on line 4, you can invoke it versus like line 4 wouldn't be possible if another function was not a function but it was an object, or if it was an array, then you can't use this parentheses to call it because it's not a valid operation. But with functions, they are. So yeah, they can be passed as parameters and you can call it. You can do all this stuff and then call it. You can like wait for something to happen and then call it. So yeah, in this case it happens to just call it right away, but yeah. So let's think of some a little bit more involved examples where basically we're dealing with parameters now. And so yeah, we're passing in calls with name, and there's 3 functions here. And essentially we're sort of combining a function to take both a string, which we're used to and we've seen before, and also a function. So that function happens to be called callback in this case. And we're going to see that term used frequently, like callback functions. Basically, what this means is, like, when this function is called, you basically, I guess, the control goes, so It's a good way to explain callbacks. Like, I mean, because it's a common term that you're gonna encounter frequently, but it's like escaping me how to explain this in the best way. But basically, when you pass a function in to another function as a parameter, a lot of times that function is called a callback function, and basically I guess what that means is when that function is eventually called, whatever, now it starts executing whatever's in that function body. Essentially you're regaining control, if that makes sense. Like it's going back to you, whereas like when you're initially just passing it in, let me
So would it be wrong to like think of it as a set of instructions?
the callback.
Yeah.
Yeah, that's perfectly. I think that's a great definition for any function. Is a set of instructions. Not
So
necessarily.
like it's a set of instructions for the higher order function. Or am I confusing that?
To an extent, yes, but at the same time, the higher order function, which is the function on line 9, calls with name, that's the higher order function because it's the one that takes in a function as a parameter. That function can do whatever it wants, but it's given that callback saying like, so when I'm done with whatever instructions that I have that I can make, call this function back. Like whatever this higher order function called calls with name is feels that it's appropriate. It's like up to the higher order function to figure out when is appropriate to call this function that it's getting passed to it. And when you pass a function into another function, you don't really have control at that point. Like you're just giving up control. You're saying like, look, like take this function and I don't know when you're going to call it. But I guess the name callback means like when you do call it, I do know what is going to run because I'm defining my callback function. I'm defining the body of it. So, I know I have control that whenever you see fit and whenever you call this function, I know exactly what's going to happen because I'm defining it here. And so I guess that kind of is like giving you the control back, call back, like, because let's say, you're passing a function to another function. At that exchange, you don't know when it's going to get called, and you're giving up control of calling that function to that function. But once that function calls your function, then you know exactly what's happening because you're the one that defined it, and that body of that callback function is going to be in, like, exactly what's happening. Like it's giving the control back to you by invoking the function that you passed in. I know it's kind of confusing, and it's okay if you don't fully grasp, because I don't think I'm explaining it in the best way, but yeah, we can just think of it for now simply as callbacks, and you're going to encounter this name a lot, is basically has to do with the function that gets passed in to another function. And usually a synonym is callbacks. I mean, you probably don't want to call it a callback all the time because it's not very descriptive of what that function is doing, but I mean, when you're defining the higher order function, I guess you could use the callback as a name, but here, you're actually calling it says hi. Like the callback function does have a descriptive name of what it's actually doing called says hi. But sometimes if you're defining the actual higher order function, you might not know exactly what the callback function is going to do, because if you're going to allow many different functions to be that parameter, then maybe you need a generic name like callback. Because the one that defines that function doesn't know exactly what callback is going to do. It just knows that it's a function and it can call it. So yeah, does anyone want to take a stab at what this is going to output to the console? When you say calls with name, Sadie says hi, and then calls with name, Sadie says bye.
Hi, Sadie. Bye, Sadie.
Mm-hmm. Yep. I guess what's important here is just that mental model of like, I'm just gonna accept that functions could be, passed as parameters, and in that process it can be renamed. So like callback is actually says hi in line 13, and it's actually says bye in line 14. So we're just going to accept that functions can have different names but be the same function. And the reason why they have different names is because now you're passing as a parameter, and now it'll take on the name of that parameter, but the execution will be the same because the function body will remain unchanged. It's just the name of the function happens to be different, and in this case it's generic and it's called callback. But callback is the function on line 5, and callback is the function on line 1, depending on what function gets passed in. So this function, what's happening here? So yeah, we could pass functions in as parameters, but we can also, yeah, I think this is just another more involved example. Not necessarily, but I was just gonna mention that you can return functions from other functions as well. Not as common as functions that are passed in as parameters, but you can also, a function can return a different function. I think this is less common. It can still be used, but it's often kind of confusing to return functions from other functions. It has its own use cases, but it does lead to an extra layer of complexity. But yeah, this isn't necessarily the same example because it's actually just returning the invocation of that function, which is a string. But anyone want to take a stab at what this would output? So we're passing a callback into calls with hello, and that callback is add world function. And so calls with hello now has control of calling the function. So what happens when calls with hello calls that function with hello as the parameter?
I would say hello world, but
Yep.
I didn't follow each step all the way through.
That's fine. I guess the first step is line 12, where we're passing in add world to calls with hello. So add world becomes func. Func becomes add world. And so when you call func with hello, you're essentially calling add world with hello. And that's going to give you hello world. And you're returning that. So you're returning the invocation of that function. And the invocation of that function is a string. So you're returning a string. Hello world. All right, this is another example, a little bit of sort of mapping and figuring out what function goes where, but basically we're passing, say, hello with name as a parameter into the say to all higher order function, which takes in say hello with name, and it's going to call that in that loop, passing it the name, which happens to be different items in a list, and it's just going to console log it out to the console. So anyone want to take a stab at what this would output when we actually invoke the higher order function?
So this would say, hello Jane, hello Jill, hello Pip, hello Mike.
Yep, perfect. So yes, again, just reiterating the concept that, say hello with name can have a alias, which is say with name func, when it gets passed in as a parameter to that higher order function. And now say hello with name, or say with name func, is say hello with name, because you passed it as a parameter and now it's taken on a new alias, but it's the same function, and it is a callback function in this case because it is the function that will get called in the higher order function. So yeah. We can pass anonymous functions into other functions too. So this is used a lot where it's kind of the same thing as we just saw, except instead of defining the function first, giving it a name, and then passing it in, we're just skipping some steps and we're just defining the function directly as in the parameter, and we're not giving it a name. Why might you want to do this? Well, if you don't want to reuse the function anywhere else, then you might not want to even bother creating a name for it, because if it's not going to be used except for in this one specific context, then maybe they're just like, oh yeah, skip naming it. I'm just going to define it directly in the parameter, and bypass the whole naming process, because it only needs a name when it's being called by the higher order function, and that name is say with name func. So this anonymous function is going to actually take on a name of say with name func when that call is made, when say to all is called. But yeah, sometimes you don't really need to define a name for it if you don't need to reuse it in anywhere else, and it only needs to be used in this one particular spot. Then it might be a time saver to just use an anonymous function and not name it. So essentially this is the same thing as before, but you're just defining the function directly in the parameter, which is perfectly legal. And you'll see this a lot in like for each loops. So, we have, array, we have like 1, 2, 3 dot for each. And then like an extra shortcut is like not even defining the function and just saying like element and just using an arrow function or something, and then call log element element. So this is a for each is a higher order function that takes a function as a parameter. And I could have done this. Same thing. But sometimes, I don't want, it's a little quicker to just say like, yeah, like I'm not going to use run in for each except for in the for each. So let me just define this directly within the function and it'll get passed in as a parameter, even though it's being defined in the same place. Does this make sense to folks? For each is a higher order function. It's the same thing that's happening here, except they happen to, you know, use the function syntax, so you could also do that too. There's like many different ways of doing things in many computer science languages. So this is the same thing. And you could imagine for each looks like, you know, it's its own function on a method, on the array method. So like let array equals, and then this is like for each is a function that takes in the for each callback function, and then say like values is 1, 2, 3 or something, and for each we'll just do it'll just loop through this, and I don't want to code everything out right now, but I mean, I guess I could. I is 0, I is less than array dot values dot length x1, and I plus plus. It's just gonna call with array with values at I, and yeah. So for each is just a higher order function that takes in a for each callback, and that for each callback is this function, and so it's passing it the element, and here we're passing the callback the element of this array. Now it doesn't look exactly like this because like this array doesn't have like a values property per se, I don't think, but I'm just trying to mimic it as close as I can. Obviously I can't mimic it exactly the way it's implemented, because it's kind of like you could think of this as an object, but it's actually an array, and that like difference is just rectified somehow by language internally, so that you can do things like, you know, I can't do array at 0, or maybe it's just like, maybe arrays are just like, it just has a property of 0, and that will be values at 0 or something, and so you could do like array at 0, and that'll give you the first element or something. I don't know how they make arrays under the hood, but the main point of this was to show that for each is a higher order function that takes in a callback. This is our callback, and it passes it an actual argument parameter here, just like how our function will take that parameter and do whatever it needs to it, and each parameter being each element in the array. So we have another example here of calc. Again, this just goes to show that because operation func is a parameter of a higher order function, it can be whatever function you want it to be. So it can be whatever function you pass in. So it's very flexible in that it can take different types of functions. Does anyone want to take a stab at what this would output to the console?
$30 and $60?
Yep. Or 30 and 40, I believe, because it's minus. The
Minus,
second,
yeah.
The second was minus. But yeah, basically the same concept that we've been going over, plus, or operation func can take the identity of plus, it can take the identity of minus. It is a variable, and by definition, variables, they can take different values as its value. And this gives it flexibility so that it can be whatever function that you happen to pass in. So yeah, callbacks, like again, that concept, like I guess what makes sense to me is when that function is called, you get the control back. Meaning like, as you're defining the callback, the function that gets passed in as a parameter to a different function, to a higher order function, as you're defining it, like everything that you're creating in that callback function is like assuming that you have control at that point, and you will get that control. Like it will be invoked at a point where it gets called, and when it's called, you get the control back, meaning like everything that you're defining in that callback is running and you have control over it because you're the one that's defining it and doing whatever manipulation that you're doing in that function. So it's calling it back for control to you, giving you the control back when it's called. Before it's called, you could think of it as you giving up control, saying like, hey, look, I'm giving you this function, like I'm giving you control. But when you call it, I know exactly what's going on because I defined it. So you're giving me control when you call it. I'm giving you control when I give it to you, because now you can do whatever, you can call it whenever you want. But as soon as you call it, I have control, like call back. That's kind of how I think of it, but as long as you're familiar with the term as a function that is passed in as a parameter, that's fine. So yeah, for each, we kind of went over this example already, but we'll go over it again. Anybody want to guess what this will log out to the console?
Be capital Brooklyn, capital Golden Gate, capital London.
Yep, perfect. And it's a little weird because, we're like, it's not even like we're calling the function. When we look at line 7, we're not calling it. And so it's like, what? Like, what's happening? But for each is calling it. And we didn't create the for each, so we have to be okay with this concept of like, we're not always going to be the ones to call the functions that we create. Somebody else might have to call them because they're the ones that know when to call it. Like, when is the best appropriate time to call it? And we're gonna have to be okay with that idea and that concept of like, we could just give something some function and they'll be the one that's calling it. In this case, for each, we know exactly what for each does. Is it basically passes the function that you give it, the element, in a loop format, and it will go through the entire elements of the array that it's defined in and pass that element to your function that you're passing in. But sometimes a lot of people are a little tripped up because it's like, okay, so I'm looking at line 7, like my function isn't even being called, but like, how is it logging something? We don't see it being called, but it's being called by the for each. You're inverting, you're giving up control to some other function. But once your function is called, you have control now because you know line 4, like you wrote that, so you know what's exactly happening. And in the body of log uppercase, like when it's actually running, like now you have control because you're the one that's typing it out. Like you have total control of what's going on. And so, yeah. So it also takes this is just something good to note, is that it takes a second argument called index, or for each basically passes index. You don't have to use it. So here's a thing I think would be good to go over an example. So the way that for each callback, what it actually does is it actually passes the index too, not only the value. But when we define our callback, we don't have to have it taken I if we don't want to. We actually don't even need to give it anything. And it just won't, then we won't have elements, so it'll be a pretty useless function. But like we don't need to, but the higher order function is gonna pass it values, but we don't need to use them unless we want to. Like it's up to us whether we want to use it or not. So in this case, the first thing that it passes is the element. So if we define it, now we can actually access it because we are saying, our callback function is taking parameters, and the higher order function is the one that's passing the parameters to the callback. So we can optionally, give it the stuff, and it will, if you want to, you can use it if you want to, but it's optional. Meaning like when you define your callback, you can have it take as many or as little parameters as you see fit, but the higher order function is going to pass them all regardless. So it's kind of like up to you how you want to handle this. So yeah, I kind of went too fast, but yeah, it's an optional parameter, meaning if you, in defining your callback, define it to take the index, then you can use the index, because the higher order function, the for each, will pass that index to your callback function. But if you don't want to use it, you don't need it, then you don't need to include it, and you just won't need to include it, and it won't be used. Now, how do we know that the higher order function passes the element first and the index second? Well, we'll know this because we have to look at the documentation in this case and figure out what the higher order function passes to the callback, because we never defined for each. So we have no way of knowing like what does for each pass to the callback function. How we would figure that out is basically going to like for each JavaScript. And I know documentation isn't the most fun thing to read for people, but here we could say, okay, so for each takes a callback that is past the current value, and index is a second argument, and the actual array itself is the third argument. So it tells you callback, the function to execute on each element, accepts between 1 and 3 arguments. The current value is the first, index is the second, array is the third, and yeah, this is, we don't have to think about this for now, but you have to read this, or otherwise you would never know that it even passed, like what it gives you. You could infer, but you wouldn't know for sure until you read this, and now you're like, okay, so like, yeah, like this is what is available to my callback function. And that's pretty much it. So there is a project on LearnDot. If you guys have extra time and you guys want to, practice and brush up on the coding skills, definitely take a look at this. It's optional 100%, but if you guys are interested, it's on LearnDot. I will unlock it, and yeah, feel free to submit it for a feedback if you guys would like. And yeah, I would encourage you guys to give it a go. Just practicing coding in different contexts will be helpful. So yeah, there's a bunch of different things that can make it quite interesting, funny, and yeah. are there any questions on higher order functions? Again, it drives the entirety of this event-based nature of web apps, in the fact that you're waiting for some user to do something and then calling a function, which changes how things look on the screen, which changes what you see, and which changes what you can do. Those are all controlled by functions, but we don't control when those are called. We give up control to the listeners on the web page, and there's a bunch of listeners on browsers, and that listen on each element. It waits until the user clicks it, and once the user clicks it, it emits an event to the listener and says, okay, the click event happened, now do something. And that thing that's being done is the callback function. And the higher order function is like the on click. So as kind of went over earlier, but we have our element is this settings thing. So let's say the settings is an HTML element, and so we could get that element, get settings element or something, right? And then that's our settings element. We can say settings element dot on click. So when it's clicked, do this thing. And when it's clicked, it does, it shows the settings. And we could define our show settings function like somewhere else, like, and we'll just pretend that it does a bunch of stuff that shows settings. And so we're saying, okay, like settings element, when I click this, right, show settings. But I can't call show settings right away because I don't want to show settings right away. I only want to do when the user clicks it. And so I need to pass this function that I define to the onClick handler. And this onClick is a higher order function that takes the function as a parameter, and we'll call it at a later point. Once it's called, I have full control of what's happening because I'm defining this function. So I could do whatever I want. I could do, blah, blah, blah. I could do all this stuff. Like I have control at that point of when it's called, but until it's called, I don't have control. I'm merely passing it in and saying like, I'm giving up control of when this function will be called. When it's called, I gain control back because I have control here when I'm defining the function. So I'm saying, when this func is called, I have full control of what happens. It's like the function is called and I get control back. So it's the callback. All right, that's the lecture today. I'm gonna unlock the workshops. Feel free to take it easy today, though. It is Friday. It's 8. We all need breathers, so I'm still gonna open up the workshops. I'll still be around until 9:40 if you guys need help. But yeah, this weekend I definitely say at least for it's good to casually get some practice in on the weekend too. But take some time to take a break too, and if a lot of this is confusing, like again, don't be frustrated. Feel free to reach out for help on individual stuff if you guys aren't getting certain problems. I would say, practice some of these workshop problems. If you guys aren't getting it, try it again, and make sure that you guys are getting practice actually coding, and like trying to engage in active learning. So yeah. Thanks for dropping by.